again, good evening. My name is Paige Northway, and I am a student with the University of Washington's Engage program, here to welcome you to our event tonight. As a graduate student, I get specialized training in how to do a very specific type of research. The Engage program gave me another type of training that graduate students rarely get. I learned how to talk about my science in a way that is engaging, enlightening, and informative. You can learn more about our innovative program at engage-science.com. Tonight's program is possible due to special collaboration between Town Hall and UW's Engage program. Together, they host a series called UW Science Now, as part of the Seattle Science Lectures. Sponsors include Microsoft and KPLU. Now, to introduce our first guest, Robin Benner is a graduate student in the Department of Oceanography. Robin studies how coastal environments change in order to provide accurate, valuable information to coastal communities that will help them adapt to these changes. Tonight, she'll be talking about climate change in coastal Vietnam. Please give a warm welcome to Robin Benner.
Thank you, Paige, for that great introduction, and thank you all for fighting the rain and traffic to get here tonight. As Paige said, I'm a graduate student at the University of Washington, and very generally, I study how little particles of mud and sand move around in coastal environments. So today, I want to convince you about two things. The first is that coastal environments can change very rapidly for a variety of reasons. And the second is that we should study these environments so that we can predict their changes and be able to adapt to how they're going to be in the future. So to start my talk, I want to tell you a story about the last time that I was in Vietnam. And I was in Vietnam on this research boat in the middle of a river in the Mekong Delta. And here I've spent about a month of my life living and working. And as I was on this boat in the middle of the river, we passed a lot of communities. And I had such a great time just watching these communities and seeing how the people went about their daily lives. So this is an example of a community that's right on the edge of the river, and as you can see, the houses are built right on top of the river. And in another community, much like the last one you saw, I got to see strings and strings of locals all come down to this little shared concrete pad, and they would kneel down, and here they would wash their vegetables, and they'd wash their clothes, and they'd wash themselves, and they'd get water, and they'd bring it back to their homes. And I really got a sense of how much these communities depend on the river. What you don't see in this picture is how much they depend on the river to irrigate their crops. Most of the people who live here are farmers. They mainly grow rice. Some of them also grow sugarcane or have shrimp fields. And all of the water that they use to irrigate their fields comes from this river. You'll also notice in this picture is how many boats there are. Every single house has a boat out in front. Sometimes it felt like it was a boat interstate on the river. And people use boats for all sorts of reasons. Of course, public transportation is one. Everybody has a small boat that they use just to get back and forth across the river. They also use it for fishing. So as I said, a lot of people here are farmers, and they also are both farmers and fishermen. And they catch these fish to both eat and feed their families, and also to sell and earn money for their families. And here you can see every single one of these little boats has a big net trailing behind it. They also use the river to transport their goods. So I said that a lot of these farmers grow rice. Vietnam is actually a net rice exporter, meaning they grow more rice than they use themselves. And 90% of the rice grown in Vietnam is actually grown in the Mekong River Delta, the area that I study. So rice is a big deal, and this boat is just loaded down with it, and these boats will travel across the river and transport their rice. But they don't just grow rice, they also grow things like coconuts, and it amazes me how much stuff they can fit on one boat, packed full of coconuts. So another thing they get out of the river is sand. And they dredge the river for sand for two reasons. One is to transport the sand and sell it, just like any other good. Another reason is to deepen the depth of the channel. If you want big boats to be able to fit in the river, you need a really deep river. You dredge out the bottom and the big boats can fit. And here is a picture. The dredge is the one with the yellow crane. The bucket crashes down in the water, gets a scoop of sand, brings it up, plops it down on the green boat beside of it, and the green boat will transport it to wherever it's going to sell it. And of course, like any other community that lives next to a large body of water, they use it for recreation. So, you know, this is what I saw when I went to Vietnam, and I instantly fell in love with the country and just had a great passion to study it. And about a week after I got back from my first research trip, I got a very unfortunate email that had this picture in it. And there was a flood of the main island and the river that I study, where almost 2,000 acres were flooded. This means like about 3.5 times the size of Discovery Park. So this is a big area. And not only were crops and houses flooded, but people were pushed out of their homes and into the river. And this flood was in part due to sea level rise. So I fell in love with the community. I found an issue that was very important to the society, and this is what I decided that I wanted to study. So I've been talking about Vietnam a lot, and some of you might not know quite where that is, so I want to zoom out a little. And if you were to open Google Earth, you'd see something like this. North America, you're all very used to it. In order to find Vietnam, you're going to have to spin the Earth all the way around to see Asia. Here, in this bottom part of Asia, I've highlighted Vietnam in orange. And this little red circle at the southern tip of Vietnam is the part of the Mekong River Delta that I study. So if we zoom in to that red circle, you're going to see land that borders water with rivers going through the land. And the river highlighted in yellow there is the one that I specifically study. And there's a lot of processes going on in an environment like this where the river meets the ocean. And to explain these processes, we're going to use this illustration that I've made. Here the land is in green, river is in light blue, ocean is in dark blue. And the river is coming towards the ocean with lots of fresh water and lots of sediment. And when I say sediment, I mean those little particles of mud and sand. And the ocean is pushing back with lots of really salty water and tides and currents and waves and things like that. And when these two bodies of water meet, it's this big jumbled up mess with currents and sediment going everywhere. And this is what I want to know about. I want to know when these two bodies of water meet, what happens. And to explain why it gets so messy when the river and oceans meet, I want you to think about oil and water. So I'm sure you've all tried to mix oil and water. It doesn't work. This is because oil has a very low density. It's really lightweight, so it's going to want to float to the surface. Whereas water is really, it has a higher density, it's heavier, it wants to sink to the bottom. It's the same thing with river water and ocean water. River water is like the oil, it's going to want to float to the surface. Ocean water is like the regular tap water, it's going to want to sink to the bottom. And you know, if all natural environments were like this, it'd be pretty simple. You can describe this cup of oil and water in about 1 or 2 sentences. But what would happen if you put a spoon in there and you started mixing it up? It would get pretty crazy. And this is what happens when you introduce things like waves and tides and currents. So I've explained why I'm interested in environments where rivers meet oceans, why I think these are so interesting. I haven't explained why I specifically care about Vietnam. And this is for 2 reasons. The first one is because of sea level rise. And I want you to think of the ocean as a giant swimming pool. If I was to stick a hose in one side of the swimming pool, the entire level is going to rise, right? It's not like half the swimming pool is going to rise faster than the other half of the swimming pool. So how is it that some places can experience faster sea level rise than other places? This is because of regional sea level rise. And that basically means how is the ocean rising in relation to where the land is? So to demonstrate this, I've made a cross section into Earth with brown being land, blue being water, basically sliced down into Earth, and we're looking at its side view here. And all over the world, the ocean is rising. And in most places right now, this isn't a huge problem because the water hasn't dramatically overtopped the land yet. But in some places like Vietnam, and you may have heard of Venice and New Orleans, the land is also dropping. And this means that the ocean does have a chance to really overtop the land and really have some dramatic effects like floods, as you can see in this picture. So to give an example, in Vietnam, by the year 2050, that's just 35 years from now, hopefully within all of our lifetimes, the ocean is going to rise about 0.1 meter. The land, on the other hand, is going to sink about 0.9 meters. That's a lot more, right? And if you add those two together, that's a total of 1 meter sea level rise. That means that 1/3 of the delta is likely going to be underwater in 35 years. All of the people living there are going to be displaced, and all of the crops that they could have been growing are no longer going to be grown. So the second reason I care about Vietnam is because of dams. And dams can be both a good thing and a bad thing. Of course, they can create energy as a good thing, but as a bad thing, they can trap sediment. And this happens because as river water is coming down towards the dam, the river water gets trapped behind the dam. A lot of that sediment gets stuck behind the dam. And even though the dams are constructed to allow river water to pass through, they're not always constructed very well to let sediment pass through. So as river water continues on, the sediment gets stuck behind. None of the sediment is able to travel downriver and maybe replenish the land. And that's one reason why in Vietnam the land is sinking, because it has very little sediment being replenished from the river. So what can happen in the future due to things like sea level rise and damming? One very obvious thing that can happen is flooding. Of course, if water rises, it's going to overtop the land and flood. This is obviously very bad. One thing that people don't normally think of is water currents. And so rivers don't travel as one body, which is what most people think. They can actually travel with one side of the river going one direction, another side of the river going another direction, or maybe the bottom of the river will go one direction and the top of the river will go another direction. And when you introduce things like waves and tides and currents, and then increase the sea level or decrease the amount of water coming down the river from dams, all of these currents can get really messed up. And this has a problem for transportation, because if you were a person in a little boat trying to row several miles along the river, you're going to want to catch the fastest current going in the right direction. If these currents change, your transportation can get messed up. Another thing that water currents can change, and which is probably more important, is sediment dispersal. So here is where I'm going to use my props. And sediment is dispersed by the water, and it's affected by two main things. The first is how fast the water is moving. So here is a bottle filled with water and sand and gravel grains in the bottom. And if I shake it a little, not much is happening, right? I really got to start churning the water and moving it very quickly to get that sediment lifted into the water. This bottle is much like this one, filled with water, but this one has very small grains of mud in it. And if you'll watch, I give both bottles the same amount of energy. This one, the grains settle immediately to the bottom. This one, the grains are now suspended in the water column. They're picked up and kept in the water column much easier and for a much longer amount of time. This means that the smaller grains are going to be picked up easier, carried farther in the water, and deposited somewhere else. Well, as the bigger grains are going to be harder to pick up, and they're not going to be transported as far. So, if sea level rises and dams upstream alter the amount of water coming down the river, how the sediment is dispersed is going to change, because the speeds are going to change, the direction is going to change, and what type of sediment is where is going to change. And as you can see by this picture, there is a ton of sediment in this river, so much so that the water actually looks brown all through the river and where the river meets the ocean. And why is this important? For one reason, I told you that they dredge sand there. So one thing we hypothesize in the future is that a lot of really small particles of mud are going to come in and be deposited on top of the sand because of sea level rise and damming. So now the people who are dredging for sand have this big layer of mud on top of the sand. It's going to be harder to get to the sand, so they're not going to be able to dredge as efficiently. And if that mud comes and is deposited on the sand, the depth of the river is going to get smaller, and the big boats that bring in a lot of goods aren't going to be able to come upriver unless they dredge all that mud out of the way. Another thing that can happen in the future is saltwater intrusion, and this is really bad. This means that as fresh water from the river is held up in the dams and sea level rises, it's going to allow all of that really salty water in the ocean to push up into the river, and that salty water is going to go where people have only seen fresh water before. And as you know, many crops like rice only want fresh water. They die if you irrigate them with salt water. So saltwater intrusion is going to cause people who normally irrigate their crops from the river to either have to find another water source or to switch to a different crop. Maybe instead of rice paddies, they're going to have to start having shrimp fields. And the last thing that I'm going to talk about that can change in the future is marine animals. So the fish who live in an environment live there because they like all of the conditions. And if the water becomes muddier or if it becomes saltier, the fish aren't going to do as well. The population is going to decrease, and that means the people who are fishing aren't going to have as many fish to catch. They're not going to have as much food to eat, and they're not going to have as much fish to sell. So I don't want you to think that the situation is hopeless. I haven't been very optimistic so far, but it's okay because scientists from all over the world, including myself, really care about environments like these, and we've all joined together and we've gone out on these research boats. The group I'm in has 3 total, and we study how the environment behaves right now so that we're able to predict how the environment is going to change in the future. And we do this by strapping a lot of scientific instruments onto the boat. This first one that I've pointed to can record how quickly the water moves and in what direction the water is moving in. This next one can form bathymetric maps of the riverbed, and bathymetric maps are just like topographic maps of land surface. They can see the depth of the water and actually what the riverbed looks like, the shapes and forms on the riverbed. And this next one I've highlighted records salinity, how much salt is in the water, and it also records how much sediment is suspended in the water. So with all of this information, we know where the water is going, how much sediment it's moving, where it's depositing that sediment, where it's dropping it off, and how far into the river the salt is able to come in. And with that information, like I said, we use it to predict what's going to happen in the future. We then give this information to the locals who are living there so that they know how to prepare. Maybe they need to build their levees higher. Maybe they need to find another source of sand. Maybe they need to switch from rice fields to shrimp paddies, or rice paddies to shrimp fields. And with this information, when things like this flood happen in the future, they're going to be better prepared and the flood won't be as destructive. So as a little recap, so far we've been talking about Vietnam. And Vietnam has beaches that look a lot like this, very shallow slopes, very sandy, muddy beaches, and it's very highly vegetated. We, on the other hand, in Washington, live here, and our beaches look more like this, right? But just because our environment looks different doesn't mean that we're not safe from all sorts of coastal change. Vietnam has problems with sea level rise and damming. We, in Washington, have problems with bluff erosion. And bluffs are what I've highlighted in red. It's basically just a cliff face made of dirt. And bluff erosion happens when waves at the bottom of a bluff are very energetic and they're able to eat away at the bottom of a bluff. This causes the top of the bluff to be very unstable. It's going to crack. It's eventually going to fall into the water. And in effect, the entire bluff face is going to retreat backwards. It's going to go further inland. So this is a problem all over the Puget Sound, but the specific place I'm going to talk about today is Port Angeles. And if you've ever been, you'll know that it's a beautiful place. If you haven't been, I urge you to go. The beaches are beautiful and the bluffs are beautiful. But if you have been, you may not have noticed exactly where the landfill is. The landfill is right on top of the bluff. So close to the bluff that trash is actually starting to spew over the edge onto the beach and into the water. And of course, the people who built the landfill didn't build it right on the edge. That'd be pretty stupid. They actually built it away back from the edge of the bluff face. But over time, bluff erosion occurs, and now the landfill is right on the edge of the bluff, and now it can start spilling over into the ocean, or into the Strait of Juan de Fuca. So another perspective of what's going on here, this is an aerial view, like you're in an airplane looking down on the land, and I've outlined the landfill in red, and you can see just how close to the water the landfill is on its bottom edge. And I want you to look around and see if you notice anything else in this picture that might concern you. I'm sure you can see, or if you can't see, there are houses that are pretty close to the edge of the bluffs. And what I've outlined here in yellow is a cemetery. That's the correct reaction. I'm glad I explained bluff erosion to you well. But just like in Vietnam, there are tons of scientists and engineers and just people in the community who care about what's going on. They've joined together and they're able to combat this bluff erosion. They're actually right now moving the landfill back several hundred yards to fix the problem. So with these two examples being bluff erosion in our own Port Angeles and sea level rise and damming in Vietnam, I hope I've convinced you that coastal environments can change very rapidly and that we should study these environments and be prepared to adapt to these changes. Thank you all very much for coming, and I would like to thank everybody and all the programs who got me here. And I would very gladly take any questions you may have.
So you mentioned that the fact that the sediment being impounded by the dam made an impact for the net sea level rise. What is the effect of the fact that they're dredging these rivers and they're removing that sediment that way too? Is that a major factor, or is that just completely dwarfed by?
It's very much dwarfed. So you probably couldn't see in the pictures, but all of the land in Vietnam, or most of the land, has levees bordering the land. So there's not much exchange between sediment in the river and sediment on the land. So if you dredge sediment out of the river and take it somewhere else, that has very little effect on the elevation of the actual land surface.
In that picture, one of the Vietnam pictures, I saw a lot of mangroves.
Right.
Is that the predominant plant species right along the edge? And if sea levels rise, would you expect the mangroves to start growing inland? And are they being cleared for shrimp farms? Because that's not good either.
Right, so it's kind of hard to see in this picture, but all of the land near the coast is bordered by a dark green, and that's a strip of mangrove fringe. And the island that we're studying, which I don't have a way to point to it, but is that it's the main island in the middle of the river that I'm studying. The mangroves are actually propagating outwards. They're moving outwards right now. So they have enough sediment to move seaward. And as they move seaward, the people come in behind them and harvest the back of the fringe. So as quickly as the mangroves are moving, the people are harvesting them, but the net change, there is no net change. And the effects of sea level rise is what we're studying right now. There's another group that also goes out and studies this river who are specifically studying the mangrove fringe. And if you have any questions for them, I would gladly get you in touch.
So you said that you were communicating some of your data to local people so
Right.
that they can be better prepared. How is that taking place? Who are you interfacing with? And have you already seen results where people are better prepared or maybe are more proactive and have switched, for example, from rice to shrimp or made other changes?
Yeah, that's a great question, because communicating the results is really the part of the project that I'm spearheading, is what I'm really passionate about. And we have not, since we just started this research, we don't have any results that we can give to the locals yet, but we are making connections and setting up ways that we can share this information. We've already made connections to a lot of professors and students in Vietnam. So hopefully if we give this information to them, they can then teach all of the other students. But of course, that doesn't mean that it's going to get to the people who actually live and work in the Delta. And that's what I'm struggling with. One of the ways that people in the Delta get their information, they don't have internet or TV or anything like that. The information is projected over loudspeakers in the community, and right now I'm working to find a way how I can get any very valuable information to be projected that way.
Hi, Robin. I have two questions. So one's about Vietnam. So you mentioned that there's changes in the larger macrofauna in the river, like the fish, but I was wondering if anybody's looking at changes in the microbial communities as a result of the sea level rise and how that influences maybe primary production in the water or nutrient levels, and then how that in turn influences farming and agriculture. And I'll wait.
Right. So the group that I'm working with is predominantly geologists. We care about the sediment and what happens there. The biology we know is very important, but it's not something that we specifically study. The Mekong River Commission does have a lot of scientists working with them, and I'm sure they do study the microbial communities. And they have a great website if you want to look up biology information on Vietnam there.
So my second question is about Port Angeles.
Right.
So you mentioned that they're moving the landfill back a couple hundred yards or meters to fix the issue, but it doesn't seem like that's necessarily a fix as much as like a temporary solution. Are there any permanent fixes that you can do to the coastline to keep this bluff erosion from happening?
Right. So this is a problem everywhere. Coastal environments change naturally, and things of this scale, there's really nothing humans can do to permanently stop it. We've tried seawalls, we've tried groins, we've tried all sorts of structures that are very controversial. Some people think they exacerbate the problem. So right now, moving the landfill is the best option. There is no way to permanently stop bluff erosion. All right, well, great. Thank you all so much for coming. And if you have any more questions, please feel free to come and talk to me afterwards.